When AI agents powered by large language models try to deal real-world tasks like booking a flight, checking stock, or getting information from a system, they hit a serious problem. These AI models understand only text, but real systems like databases, APIs, file systems, and business tools don't speak natural language. So the big question is, how does a text-based AI reliably talk to a real software systems? That's where protocols comes in. Hello friends, welcome back to Nakma's Tech World. And today we will talk about a protocol built specifically for AI agents, Model Context Protocol or MCP. In today's video, we will cover what is MCP, why MCP is needed, MCP core concepts, runtime discovery, MCP architecture, and a simple flow showing how AI agents use MCP. First of all, what is MCP? Here MCP stands for Model Context Protocol. It was introduced by Anthropic in late 2024. In simple terms, if we understand, MCP is a standard protocol that allows AI models to connect to tools, data, and software systems in a structured and reliable way. For example, imagine you open a food delivery app. If you see one example, imagine you open a food delivery app on your phone and you can easily see nearby restaurants, right? You can check the menu, or you can place an order and make a payment. All of this works because the app already knows how to communicate with the restaurant system and payment system. Now, think about an AI model. If you simply tell the AI, order a pizza for me, the AI understand what you are asking, but by itself, it cannot actually complete the task. The AI cannot open restaurant system, it cannot check menus, it cannot place orders, it cannot make payments. Not because the AI is weak, but because AI models only understand text. They don't know how to directly interact with real-world software systems. Now imagine MCP as a standard rulebook. Okay, this rulebook clearly defines how an AI should interact with a restaurant system, how it should request menu data, how it should place an order, and how it should use payment tools. Here with MCP in place, when you say order a pizza for me, the AI does not guess. It follows a clear predefined process given by the MCP. Okay, it uses the restaurant tools, it fetches the menu, it selects the item, it calls the payment system, and it confirms the order. So here everything happens in a controlled and structured way. Okay, so this is how AI agents use the MCP protocol to safely and reliably interact with the real world systems. In simple terms, if we understand, MCP like a common language that allows AI to correctly use tools, data, and software systems. Now, why MCP is needed? Large language models such as GPT and Claude have two fundamental limitations. Okay, first, they operate with a limited context window. They cannot hold entire databases, full applications, or continuously changing real-time data in context. Okay. Second, they only know what they were trained on. They do not automatically have access to today's data, live systems, or user-specific information. Because of this, pushing everything into the AI's context is neither practical nor scalable. Instead, a better approach is to allow the AI to fetch information only when it is needed. This turns the AI agent into a decision maker. It decides what it needs, it decides when to fetch it, it decides which tool to use. In other words, the AI becomes a decision maker, not a data container. Here, MCP provides a clear and standardized way for AI agents to request context, interact with tools, and retrieve external information. That is why MCP is needed to reliably connect text-based AI models with real-world systems and without overloading the model's context. Now let's understand the core concepts of MCP. These core concepts are the basic building blocks that explain how MCP works internally. Here MCP has three core concepts. Each one is designed so that an AI model can clearly understand and correctly use the real-world systems. Let's go through them one by one. The first core concept is tools. Tools are actions that the AI agent can perform. For example, an AI agent can check the weather and look up customer information and also read data from a database or even send emails automatically. Here, every tool comes with a clear natural language description, and this description tells the AI what the tool does and when the tool should be used. So because of this, the AI does not guess, it clearly understands which tool to use and why. The second core concept is resources. Resources are information sources, not actions here. For example, resources can include database schemas and that explain how data is structured, and API documentation that shows how systems communicate, and configuration files that define system settings, and so on. Here, resources help the AI to understand the structure of data and the context behind it. So instead of blindly calling a tool, the AI first understands how data is organized. The third core concept is prompts. Prompts are interaction templates. They guide the AI on how to talk to a tool, how to format requests, and how to interpret responses. This ensures the AI communicates in a consistent and reliable way every time. Here, together, these three core concepts make MCP AI friendly. They allow the AI agent to understand what actions are available and to understand what data exists and to communicate correctly with the real systems. So this is what allows MCP to safely and reliably connect AI agents to real world tools and services. Here, an AI agent no longer requires prior programming for each task upon connection. It asks the system to identify available tools and resources. This capability is known as runtime discovery, a key feature of MCP. Okay, when an AI agent connects to an MCP server, it can simply ask, "What can you do?" The MCP server responds with available tools, available resources, and available prompts, each one explained in human readable language. This means agents don't need to be retrained every time something new is added. They can learn about changes instantly, and new tools or features can be added to the system at any time without disrupting the AI. The AI can adapt dynamically. It means it adjusts and works with whatever is available right now without needing manual updates. So this is something traditional systems were never designed to do. Now let's understand how MCP works behind the scenes. In an MCP setup, we have a host application, one or more MCP clients, or an MCP server. The MCP client connects to the server using JSON RPC. Okay, then the MCP server acts as a wrapper around real systems like databases, APIs, file systems. So the flow is simple and structured here. Okay, AI to MCP client to MCP server, and MCP server to external system, and the response flows back the same way. So this keeps AI logic clean and system access controlled. Let's understand how AI agents use MCP behind the scenes. It starts when a user sends a request like get customer order status. The AI agent first understands this goal, then it asks the MCP server, what capabilities do you have? This is called runtime discovery, which we have discussed before. The MCP server responds by listening available tools and resources. Next, the AI agent selects the right tool and calls it via MCP. The MCP server then invokes the external system such as a database or API. Once the external system processes the request, it sends results back through MCP server to the AI agent. Finally, the AI agent sends the result back to the user. All of this happens dynamically without needing any retraining, allowing the AI to adapt smoothly to new tools and information. Overall, to understand MCP, remember one line: LLMs are the brain, MCP is the bridge, and AI agents are the workers that get things done. So thanks for watching this video. Have a good day.